Very good morning to all. I am Dr.N.STALIN, working as Assistant Professor, Senior Grade in the Department of Petrochemical Technology, Anna University, BIT Campus, Tiruchirappalli. In my topic of this conference is design and performance evaluation of shell and tube heat exchanger fitted with automotive engine along with the O3 filter in the exhaust of automotive engines. See, my main aim of this research is first of all, I gone through the existing problem available in, especially in India. If you take city like Chennai, Mumbai, and Delhi, and all over all the metropolitan city in India, they are very struggle to get fresh air for the common living people because of more vehicle pollutions. More vehicle population in India is nowadays grown from the year 1952 in 2020. Almost it has to be triple the times, triple and four times. And the main problem for the people, they are not getting fresh air. Because of that, every people, every even a child, very struggle to get fresh air. So my idea, I have to fitted a ozone filter which we manufacture from LG company. This ozone filter with a different thickness with a porous in nature. So that filter I have to fit it at the exhaust of a vehicle engine, and also in the exhaust heat available in the any diesel engine or petrol engine. By adopting and by designing one shell and diff heat exchanger, and that shell and diff heat exchanger I fitted in the outlet of the engine exhaust. So my idea is the whatever the waste heat available in the engine, that has to be recovered by using a shell and diff heat exchanger. One side of cell side, I have to allow this all the whatever the flue gas emitted from the vehicle is allowed through the cell side, and tube side I allowed the normal water, which is the tap water, which is allowed through the tube side. So whatever the water, normal water, which is supplied through the tube side, it gets evaporated and it forms in the form of steam, and the steam has to be, I put a small condenser. So the normal water is converted into distilled water. My aim is to recover the waste heat as well as the normal water is converted into distilled water. And also the existing problem available in the automotive car engine system, there are a variety of issues are running. Number one, the automatic car engine has a conversion efficiency is minimum because of considerable amount of waste heat emitted to the atmosphere. So that is the one method I have to use and recover the waste heat. The existing automatic car engine has allowable limit of CO2 emission as further increasing the atmospheric temperature, and it has to pollute the environment. So by using a O3 filter, because the ozone filter is one of the main filter, our ozone layer is the only layer which is responsible for protecting all emitted gas from the atmosphere. So I have to, my idea is to making a O3 filter with the help of LG Coimbatore, and this filter has to be attached in all car engines. So that will absorb whatever the CO2 or carbon monoxide is emitted through the gas that exhaust of the engine, and also I recover the heat available in the exhaust. So CHP system has to be adopted in the existing car engine, not adopted, but my idea is to adopt the CHP system. And the fuel consumption, proper air fuel ratio has to be optimized for any combustion reactions. And flue gas continuous monitoring system has to be adopted. The waste recovery not tested in the existing method. Design of waste heat recovery system with optimal cost is a major challenge, and exhaust flue gas has not cleaned the proper filter design without affecting the flow of flue gas is a major challenge. So these are the problem I identified. So my objective to implement the new concept of CHP system to design and achieve the maximum possible heat recovery, to design a suitable shell and tube heat exchanger for recovering waste heat, to investigate exhaust flue gas outlet by adopting flue gas analyzer, and by connecting O3 filter as reducer particulate matters. So to incorporate CHP system model using the different thermocouple to monitor the temperature and output gas analysis in the different running conditions. To improve the overall maximum efficiency in the engine, waste heat is utilized to convert dirty water into distilled water. And the practical model is developed, which is simple and affordable, as it is used as a low-cost control mechanism in the consequent to the low computational requirement of the proposed techniques. So this is the CHP system. The so here you can allow the exhaust gas through the shell side, and inside the tube side you can allow the water, and every point you have to fix some of the thermocouple which is used to monitor the temperature and to make the what is the average temperature of the entire flue gas. So the whatever the coolant which is supplied to the inside the tube, it is get evaporated. So the outlet is coming, you will get a steam. So that by adapting one condenser, so it condense the water and make it as a distilled water. So that is a simple concept. So the experiment include the temperature measurement. So we use T-type thermocouple in several point, almost 13 point. So beside with the entire measurement lengthwise of the heat exchanger, schedule top of the cooler and inferior cooler make contact with the surface through the heat exchanger. So water flow measurement and coolant flow through the heat exchanger. The temperature of the exhaust gas measurement in packet and to the back the thermal energy exchanger. Fuel consumption quantity with the time. And the air consumption measurement and the flue gas analysis also parallelly we have done. And conventional power measurement, water graceful, the cooler expecting the top and bottom shell of the thermal exchanger also measured. So this is a simple system which we used. So at the outlet of the engine, we fitted with the O3 filter, and the flare gas is also continuously monitored with the flue gas analysis, and we tested with the diesel SI engine, self-ignition engine. So first I allow to measure the temperature with respect to the gas. So up to 20, after 25 minutes, the temperature of the gas output is constantly comes about 600 degrees centigrade. And when we consider the combustion, the heat with respect to the torque. So when we go for a higher torque, the combustion heat range is also high, and the exhaust gases is emitted from the engine. Okay, that will increase the engine power, rate of the engine power. So we have to require using the heat exchanger with different type. But why I have to choose this shell and tube is easy to recover, and compared to other type of exchanger, this easy to clean and easy to recover the heat. So this is a CO2 emission through flue gas with and without O3 filter. We tested without O3 filter. So we have emissions. The blue color is CO2 emission is very high. Okay, so with respect to the time, and also here the CO2 emission minimum with respect to the without filter, with the filter is minimum, and temperature is also we measured in different point with respect to the time. So this goes to the maximum range of 600 degrees centigrade, and with the different RPM and different torque we have measured that, and for a higher RPM which will give you more output of heat. And also for the with respect to the engine power, what could be the temperature and the inlet and outlet of the heat exchanger, and what would be the optimum level after adopting the filter. So we tested with experimental, and the gas outlet after recovering that heat, that is reduces to nearly about 150 degrees centigrade. So if I reduce further, what happen again? There will be a due to the reduction reaction. So this carbon dioxide is converted to carbon monoxide. So when you emit carbon dioxide in terms of carbon monoxide, that is very dangerous. That is what I restricted to recover the heat only up to 150 degrees centigrade. So the design optimization of heat exchanger were experimentally studies with O3 filter, and we tested with different RPM and different kilowatt of heat can be absorbed. Almost 50% of increase in efficiency with respect to the existing one. And the main achievement of this experiment, the exhaust temperature reduces to 600 to 300 degrees centigrade. The experiment concludes that the possible of recovering 80% reduction in heat, but to avoid reduction reaction in the existing fluid. And also the heat energy power is equal to the power of the car 1.4 dm cube engine capacity, typical alternator used for the car. The research paper conclude that the CHP much greater macro level research has to be updated based on the micro level design with or without O3 filter of any type of diesel as well as petrol engine is possible. The crispy of research is having scope to make the challenge to reduce exhaust heat and increasing the CHP system efficiency with the optimal design of residence time. Heat exchanger size for the different flow pattern of waste heat recovery system will improve the overall efficiency by 20% and reduce the pollution by 50%. So thank you for your opportunity. So this is a pilot model we studied. We had a proposal with Tamil Nadu Energy Development for adopting this type of model in all car engine and two-wheeler also. We had a MOU signed with the Tamil Nadu Energy Development Agency. So after getting the rights from the, or after getting the proper patent rights, we have to adapt in all the system to the all vehicle with the help of the government. Thank you. Thank you for your patience. Listen here. If you have any queries, you can feel free to ask any questions. Thank you. Thank you once again.